What's going on, everybody? My name is Shashwat. I'm CEO of KITE, and this will be the second video of our machine learning course. And today, specifically, we're going to go over at a high level what neural networks are, and we won't get to coding today, but we will get to it later in this course, so stay tuned. So let's just get into it. What are neural networks? So if you've seen the previous video, you'll know that neural networks are one of the supervised machine learning algorithms. Basically, they kind of try to mimic the human mind. Um, they do this by an interconnection of many layers of nodes, and each of these nodes have inputs, weights, a bias, and an output. That's very confusing. What does it mean? I understand. So, to better explain this, I'm going to give an example, and I'm going to give an example in, I guess, terms of real estate. So, here we have the input layer. These will be sort of sorry, the factors determining what makes a house priced well, and output layer is obviously the price. So for my inputs, I'll go ahead and I'll say age, location, and square footage, how big the house is. You might be thinking, okay, now why are these layers here? What are the purpose of these layers? And basically, the reason why you have these layers is you want to determine patterns in the data. So, for example, age and location. Maybe at a certain location, all the houses are pretty old. So, you know, when you're thinking about that, let's say this node is the one thinking about that, it sort of realizes, okay, wait, in this location, every house is old. And if every house is old in this location, that shouldn't really make the price worse, right? Or things like location and sorry, square footage and location. All the houses in this location are small. Think about like New York. There's not a lot of space. All the houses are small. And so they're still priced highly though. And you kind of have to think about those patterns. And that's what these hidden layers sort of do for you in the neural network. So as you can see, this is kind of like the human mind. It's kind of learning backwards. So it the process of training a neural network consists of basically having a list of not just like tens, but I'm talking thousands, sometimes millions of lists of the three factors like age, location, square footage, and then price in like a spreadsheet. So think of like age, location, square footage, and price, and then like thousands of rows in a spreadsheet. That's sort of the data that we're going to be training this neural network on. And of the thousands of houses that it learns, it's eventually going to realize certain patterns in the data, and that's what these hidden layers are for. So it's going to pick up on those patterns, and eventually, at least the goal would be, is that when you give it a new house, I mean, not a new house, but a new age, a new location, a new square footage, it will accurately determine the price it should be at. Now, how does that happen? Like, this is sort of just magic still. Um, what is the driving force here, right? That makes these pick up on the patterns or makes any of this actually work? And we're gonna get to that a lot when we come to the implementation, but we'll also explain it here. Okay, so they learn this through supervised learning. Now, what is supervised learning? I know I briefly touched upon it in the sort of last episode, last video, but um, really the mathematical or programmatic way that it's defined is you have to minimize the loss function or cost function, depending on who you're talking to. Um, so what is the cost function? This is kind of something that's so what is the cost function? this is, and bear with me, it's gonna get a bit abstract and mathematical, but I promise this is the only video, one of the only videos that's gonna be like that. So basically, we said it needs to it needs to reduce the cost function, right? The cost function is given by this. Okay, now you might be thinking, okay, where did all these letters and weird math symbols come from? I get it. It's confusing. So let's just take it one step at a time. So input values, these x1, x2, xm, don't be confused. These are still the age, location, and square footage. They just make it as variables, like to abstract it, it could be anything. But age, location, square footage, for example. Weightage. Now, weightage is how important basically these things are. We don't set the weightage. The idea is for the neural network to learn the weightage itself. And really, the crux of a model is in the weights, really, because the weights are what determine the price, really. So, like, how much this is valued, this is valued, this is valued, is really what's important. Because if you think about it, like let's think about houses. If the weight for location was nothing, right, and it's just about square footage and age, then you know places like New York or London or Paris, I'm assuming these are like old cities that are kind of tight on space, those houses would have been cheap. But clearly that isn't the case because the location, they're in big cities, a lot of opportunities, a lot of demand. So the weights are really the crux of any model. Now, what is this phi function? I know it's kind of evading people. That's the Greek letter for phi. That's just fancy math writing for the activation function. So, what is the activation function? What does that mean? That means basically, if we're going back here, things like let's say the weighted, like this node kind of calculates the pattern, like of the age and the square footage, like, oh no, sorry, location and square footage. For easier, let's make it that location, square footage, and this is the node. So the weight between here is going to be minimal because between age and this node will be minimal because we're going to say, just for the purposes of an example, that this node is really going to be concerned with just location and square footage. So let's say this weight is really nothing given by the neural network. Now, maybe, we consider it to be important, but maybe in the next stage that maybe it happens that in the next stage it's not important. Sometimes it happens not to be important. Or maybe um like things like the input has to be so large or so extreme for it to actually, like, it needs to be above a certain threshold for that node to matter. Like maybe the relationship between location and square footage isn't really all that important unless there's some outlier or unless it's bigger than something. And that's what the activation function is. Basically, it could be whatever you want. It could there I think I go into it. Okay, I'll go into it next video about activation functions. But there are different types of activation functions. Rectilinear, um, I think it's sigma or something. I'll make another video on it, definitely, very close to this one. But those activation functions kind of determine, okay, this is important enough to be counted, so we're going to pass on this value to the next node or to the output. We're going to contribute to the output. Or it's going to say, okay, this is like an external factor, but really doesn't mean anything. So we're just gonna cut it. So that's what determines that basically. And then you get y hat. So after every node, so every node connection, so this node to this node, 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 every node like going out has this y hat. This y hat is the output value of that node, right? And actually, I'm sorry, let me correct my mistake. The out the output value, right, is actually the output value here in the output layer. That's my mistake, guys. The output value is the output value from the output layer. That gives you y hat. So let's so what that means is this is y hat and this is actual y. So y hat is basically just the estimation that your neural network gets. Your cost function will be the root mean squared. I think it's root mean squared. There are different types of cost functions depending on what you want to do. But just for simplicity's sake, this is the most common one. And if you notice it, it's just looking at the distance between the estimated value of your neural network and the real value of the. So when you're training it, you'll have all the input factors and the actual price of the house. Like I said before, it compares it. It compares the estimation compared to the real cost, and that's the cost function. So basically, or that's the loss function, how inaccurate your model is. And it wants to minimize that, meaning it wants to minimize the inaccuracies of your model, making your model more accurate. So how does it do it? So it yeah, how does it minimize the cost function? And how does minimizing the cost function change the model? So this is called gradient descent. And there are different types of gradient descent, like stochastic gradient descent, other things as well, and they're very mathematically complex. And really, to implement a neural network, you don't need to know the maths behind it. Sort of like, you know, using a car without knowing how a car works. So we will link the papers in the bottom of the video if you care to learn it, but really it's not needed, so I won't go over it because it's too, we don't want to like scare people off that have math phobia or whatever, so we won't cover it here. And then how does minimizing the cost function change the model? So how does it physically change these weights, or how does it determine how important these nodes are? Well, that's actually a mathematical equation called backpropagation, and that's even more complicated. I recommend the 3 blue 1 brown video. It's perfect at explaining backpropagation. I'll link other sources here, of course, but yeah, those are the two like heavy math things not required, but involved in neural networks. But apart from that, there isn't much mathematics. You don't need to know a lot of math. And the libraries that are there and available in Python kind of simplify the work a lot. So to implement a neural network is actually a lot easier, and you don't need to know the math. If for whatever reason you want to learn the math, we will link resources in the description. And I yeah, so this will get started with next time because the video is running long as it is. So thanks. Be sure to if you're a high school student, be sure be sure to follow our Insta, so our handle. Try and start a chapter if you're a high school student and your school doesn't have much coding curriculum. And like and subscribe, and thank you.